Hello, everyone, and welcome to our webinar, How Digital Asset Research Ditched MySQL for 1000x Faster Performance and 50% Lower Costs. My name is Matt Brown, and I'll be your moderator for today. Before we begin, just a few logistical reminders. Today's discussion is being recorded, and you're currently in a listen-only mode. You may submit questions throughout the session using the Q&A functionality in the lower section of your Zoom console. If this is your first time joining a SingleStore event, heads up that we sponsor regular webinars and events demoing data, AI, engineering use cases, and technologies. And actually, the next big thing that we're looking forward to is the Real-Time AI Conference on October 17th at the Chase Center in San Francisco. And today only, SingleStore is sponsoring discount codes for this audience. You can grab your $25 ticket right now. That's usually $199. All you need to do is click the link that's on your screen. I'll put that in the chat in a minute and enter the code SingleStore-25 during checkout. I will put that in chat as well. Or if you prefer, you can snap a screenshot of that QR code or a photo of that QR code. And hopefully we'll see you there on October 17th. But we can get back to today's topic. FYI, we have fantastic experts who will also be joining our Zoom Q&A. They've got a good grasp of the topics that are being discussed, and they're ready to answer your questions interactively. We'll try to get to as many of the questions as we can as they come in, and we'll look forward to discussing some during the live Q&A as well. So one more note, we'd love for you to try out today's technology. In fact, anyone who tries the technology that we're going to be talking about today will be entered for a chance to win some new branded AirPods Pros. All you need to do is click that link. I'll put that in the chat as well, or that QR code. And if you log into SingleStore, you will be done. If you've never tried it before, there's a free trial if you're a new user. Or an existing account, if you're already a customer, or if you're in an ongoing trial, all you need to do is click that link, log in. We will check the folks who have logged in, and we will announce a winner by the end of today's session. So let me introduce our speakers for today. We are honored to have Michael Zimberg, the CTO of Digital Asset Research, a leader in providing clean digital asset data for institutions. With a rich background in Fintech, including stints at Citigroup and Morgan Stanley, Mike combines deep capital market experience with a passion for digital assets. He's been at the forefront of innovative data solutions, and we're excited to hear insights from his vast expertise today. We're also joined by Vijay Raja, a veteran from the realm of product and solutions marketing, currently overseeing product marketing at SingleStore. Vijay has an 18-year career journey spanning roles at leading organizations such as Cloudera and covering diverse IT domains like big data analytics and AI. Vijay has been pivotal in shaping our product marketing strategy and our competitive positioning at SingleStore. Welcome to both of them. Vijay, I think you have the floor first.
Awesome. Thank you, Matt. Thank you. Appreciate it. Good morning, good afternoon, good evening, everyone, wherever you're joining in from. As Matt mentioned, my name is Vijay Raja. I'm the Senior Director of Product Marketing here at SingleStore, and very excited to be here today with Michael from DAR, Digital Asset Research, to talk about their journey and how they're powering one of the fastest growing fintech applications today. Okay. Now, as part of this discussion with Michael, we'll talk a little bit about the DAR platform, the Digital Asset Research platform, and what it enables customers to do. We'll double click a little bit on, Michael will talk about some of the data challenges that they were going through and what they were looking to solve for. He'll also talk about their data journey, how they got started, where they are now. He'll talk about their current architecture with SingleStore and what it enables them to do for their customers. Most importantly, Michael will also showcase the platform live on some of the cool features that they've been building out. Okay, but before we jump into the details, I wanted to spend some time going over the basics of SingleStore and provide you all with some context, especially for folks who are not that familiar with SingleStore. Okay, so let's jump in. So what is SingleStore DB? The easiest way I try to explain is SingleStore DB is a single unified database that you can use to transact, analyze, and contextualize on data in real time. Now, what does that mean? In plain English, what this means is it's a distributed relational database that can do transactions, OLTP, analytics, OLAP, together with vector capabilities in a single engine without any data movement. Okay, so it essentially becomes your single store for your applications. Okay, so you might be wondering that all sounds good. How do you guys do that? So the way we do that is when it comes to transactions, SingleStore has an in-memory row store that can do extremely fast writes and fast record lookups. Now, keep in mind, we are built as a distributed SQL database that's horizontally scalable, right? So what that means is as your data grows, as your needs grow, you can scale out horizontally by adding more nodes. Okay, so that's kind of the transactional aspect. When it comes to analytics, we also have a column store, or what we call the universal storage, that is used to drive high performance analytical queries or to run large scale aggregate functions. And speed is really our DNA, right? So when we do queries, we deliver millisecond latencies. And it is due to this unique combination of a row store and a column store in a single engine. That's what enables us to do that. And of course, with the column store, you also get 80 to 90% compression ratios to help keep your costs down as well. Okay. Now, last but not the least, contextualization, right? What do I mean by that? This is really where the AI and vector capabilities come into perspective. Now, we have done a number of webinars on this. We have done a number of workshops on this. If you're interested in learning more about vector capabilities, feel free to check out the SingleStore website under resources, webinars. You'll find a ton of valuable resources that you can leverage. Now, when it comes to vectors, SingleStore has had vector capabilities since 2017, way before the Gen AI revolution got started. And we already have customers today that's using it to power things like semantic search, image recognition, powering chatbots, so on and so forth. And we also have notebooks that allows you to run Python code along with SQL on top of the database. Okay. So again, what all of this really does is now you have a single platform that you can use for transactions, analytics, and vectors in a single engine. And a lot of our customers like Digital Asset, they're leveraging this to power SaaS platforms, to power customer-facing applications, to power real-time analytics. And you can expect something like 10 to 100x better performance and usually 1/3 the cost. And obviously, this eliminates the unnecessary data movement, eliminates ETL, and a lot of the complexity that goes along with this. Okay. Now, to put it in a little bit more context, how does this fit in with your ecosystem? So as you can see, with SingleStore, there's a native functionality called pipelines, and you're going to hear a lot more about pipelines from Michael as well later today. But what it essentially does is, think of it as a high throughput streaming ingestion. You can use pipelines to do like millions of events, ingest millions of events per second from distributed data sources such as Kafka, Azure Blobs, AWS S3, Google Storage, or HDFS, so on and so forth. So you can now bring in millions of events per second into SingleStore and do analytics or do queries on it as the data lands. So remember, we talked about the fact that we are a unified engine, which means you can use us as the transactional and the analytical engine. No need to have a separate analytical database, move the data from an operational database to an analytical database and to do queries or to do fast analytics. You can do all of it just with using SingleStore. Okay. Beauty of it is it runs anywhere. So you can run this on any of the leading clouds, AWS, Google Cloud, Microsoft Azure, or you can run this on premises, right? So we have multiple customers who are running this on premises or on any of the leading clouds or in a hybrid mode, right? The other aspect to this is I mentioned the fact that we are a unified database, but the beauty of it is also a multi-model database. What do I mean by that? We are a relational database, so obviously we support structured data, right? Relational data, SQL data, we obviously support that. But we also have native support for other data types, including JSON data, full text search, time series data, vector data or vector capabilities, right? Geospatial data. And what that means is you now have a single engine where you can kind of ingest all of these different data types, mix and match these data types, and use that to power either your real-time applications, customer-facing applications, or do real-time analytics, right? Or in a lot of the cases, like what Michael is going to cover today, applications with analytics, applications that serve analytics to their end users, right? So this becomes extremely easy and powerful. So we make it really fast, easy, simple, and efficient, basically, okay? Now that you have a little bit more context on SingleStore, let's talk. I want to spend too much time here, but just to give you a key idea of some of the key product capabilities that we're going to be talking about today, and Michael will double click on a lot of these as he talks about their, the DAR journey and what they're utilizing for. So a few things I want to call out. Number one is what we call the patented universal storage. So traditionally you have databases, you have a row store or a column store, right? In SingleStore, what we have is a unique table type called universal storage, which combines the best of a row store and column store into a single table type, right? So that way you can now process transactions and analytics in the same engine using SingleStore. As I mentioned earlier, speed is in our DNA, and when we do queries, we deliver millisecond latencies, right? Millisecond response time. And it is due to the fact that we have a 3-tier architecture. Remember, we have in-memory row store, disk space column store, and the cloud object store. And what that enables you to do is utilize the power of in-memory capabilities, utilize the power of column store for analytics to power really, really fast queries and fast analytical queries and operational queries, okay? I talked a little bit about the ultra-fast ingestion with pipelines. We'll be dwelling a lot more into that in our conversation. I also mentioned about multi-model capabilities, right? So think about the fact that, if you're an organization, obviously you're not just dealing with SQL or structured data, right? You want to be able to combine SQL with JSON. You want to be able to combine SQL with vectors, with time series data. And that's what we make it possible in the platform. We also recently launched a MongoDB API called SingleStore Kai, which lets you power up to 1000x faster analytics on JSON compared to doing analytics on MongoDB, right? So again, lots of interesting functionalities, but again, we kind of package this together, bring this together in a single engine to make it easier to power modern applications, modern SaaS applications, especially applications with analytics.
We provide institutional quality market data on digital assets. It's a tricky thing to get right, given that there aren't often standards in the space, and one exchange can refer to an asset as something and another exchange as something else. So we've got a way to have all that data come together in our reference master, and then we have a high quality set of prices that we do at many different frequencies that do things like factor out potentially market manipulating trades or flash crashes, which might have been specific to one exchange that firms can rely on to mark their books. We also do asset vetting. We do exchange vetting. So we rank all the exchanges in terms of their quantity, in terms of their quality based on a number of quantitative and qualitative criteria. We do due diligence on counterparties. And more recently, we're doing a lot of work in the ETP and tokenization areas.
Very cool, very cool. Can you maybe provide a little bit more color on when you were started, like, and some stats and about how you guys have grown in the last few years, maybe?
Sure. So I've been at digital asset research coming up on 2.5 years. When I started, we were using MySQL in AWS with every consumer writing directly to the database. So because MySQL doesn't have the beauty of what you described earlier with things going into a row store and then a column store, the database would frequently lock. I would get woken up in the middle of the night. I would have to do something and fix it. And we can handle in the order of about 10 million trades in a day. That was about our limit at that time. So fast forward to today, we are paying less than we were for the MySQL instance we had. And a normal day looks like about 150 million trades, and we've handled upwards of 1 billion trades in a day. the speed at which we have to query has also changed pretty dramatically. When I started, we were pricing about 200 assets only at a 15-second frequency. Now we're pricing over 10,000 at all kinds of different frequencies. We still have 15-second, but we also do a 1-second price that goes to the Bloomberg terminal, and we do a 400 millisecond price that we send to Chainlink and Pith. So in this way, we need to consume the trade. We need to normalize our trades, dedupe them because we collect multiple times, and have that highly available for multiple queries. So we're looking at querying tens of thousands of times a second in some cases, but then also retaining all those trades so we could do analysis on it.
Interesting, very interesting. So 150, 200 million trades a day, sometimes over a billion. Obviously it's very challenging environment and very demanding environment, I would say. But I have to ask you this though. Obviously it has been a tough year for crypto in general, right? It's been a tough year for financial markets, specifically for the crypto markets. Tell us a little bit more about how has that impacted your business? I mean, how has that changed what you do, if you will?
So we're feeling the hard times just like every other firm, and it is tough right now. But what we've been able to do is make things that have a solid foundation so that they can scale once the good times return.
Yep.
I don't have a crystal ball, and people that know me that are listening will know to usually you should bet against me if I give you some kind of investment advice. I'm usually wrong, which is why I'm a technologist. But it could be Q2 of next year when things start to look better. But we have lots of other things in place like SingleStore that we can just click up if we need to. And we're doing things like clearing down tech debt and making it possible that once we have lots of institutions that are getting involved in the space, we can help them.
Mm-hmm. Very cool. Awesome. So obviously, 200, 120, 50 to 200 million trades, but digital asset research does so much more than pricing, right? You have a whole set of product offerings that you guys offer customers. So can you give the audience a little bit of flavor on what kind of products do you offer and kind of who do you serve?
Sure. So we've got a reference master, which is a bit different than what you might think in other markets like equities or fixed income, where we need to identify over time because there's no such thing as a consistent corporate action. There is some of the time when there's things like hard forks, but other times exchanges will call something else. Yeah. And something else we've recently started doing is what we call verifiable volume. So we have a system that tiers prices. So if we're able to produce a price from only our very highest quality exchanges that follow all best practices like KYC and pass all our tests, we call that a tier 1 price. Mm-hmm. And an asset like Bitcoin would, of course, be a tier 1 price. There's others that would come from a combination of our vetted and the category right below, which we call watch list. And what we do for verifiable volume is that whole universe of vetted and watch list we include together. So it's a volume that we can be confident is reasonable. We've got a taxonomy product where we categorize the assets, and we do all this diligence. So not just on exchanges like I described, but also on the assets themselves and how they work and how their tokenomics look, but also where they're listed and what kind of adoption they have and what kind of we do things like a network analysis. Like, is it passed between a few holders or is it passed between lots of holders? We do ESG. We look for health of the network. So things like how many developers are active in GitHub and how many are working on it and how many institutions have adopted it. And then we have a blockchain product that we're building out as well, where we've got some raw blockchain information, and we have some that's derived, like the concept of yield. So we collect and derive and send out yield. So you could derive something like an APR if you were to stake your Ethereum, for example.
Wow, I can just imagine the complexity of the business, just given so many different products and the real time nature and how data driven this has to be really successful in this. So kudos to you guys for pulling these together and really driving growth in such such market conditions as well. So, but here's the thing though. So so speed and performance are obviously critical, right? When it comes to asset pricing in your whole business, crypto pricing, whatever you guys do. And I think a lot of your customers, I think you mentioned this, a lot of your customers demand sub-second pricing. Can you talk a little bit more about, kind of the real-time element of it and like the sub-second pricing and the pricing details that your customers really demand from you?
Sure. So I think the most demanding clearly is we do a price every 400 millisecond for Chainlink and Pith. So it's 2.5 times a second. As long as there's a trade, we will derive a price. And there's a lot of steps involved in that. So we need to collect all the trades. We need to dedupe them. We need to normalize them. We need to get them loaded, and we need to query them again by the pricing engine, where it goes through all the steps, like looking at each exchange to see if one exchange is behaving abnormally, so it can be thrown out of that period, to next look at each asset to see if the asset on the exchange is behaving abnormally, and then do things that throw out things that are way off market. And then finally, whatever's left, it's got to take that and do a VWAP. And by the way, all that has to be dollarized. So we have an
and all that under 400 milliseconds.
That's right. Every 400 milliseconds, 24/7.
Wow.
No maintenance windows, and it's been fun. So you can think about doing things like deployments, upgrades. We do all that in a way that we can still be running that whole entire time. So it's in the order of 5 to 6 billion prices a month that we stamp in that 400 millisecond engine. And it would be great if the 1 second engine could use some of those outputs of the 400 millisecond engine, but it can't, because each period is really distinct and it has its own data that it knows at the time it ran. So each of these is a totally distinct engine and needs to query the trades immediately, or we wouldn't be able to keep up. So we stream 1 second prices on the Bloomberg terminal. And then our 15-second engine is used by many clients. And then we have derivations off that. Like we have what we call a close price, but given that the crypto markets are never closed, we do one of those every 30 minutes, a time-weighted version of our 15-second price.
Wow! After that 400 milliseconds, everything else seems like a eons away, right? Like 15 seconds seems like a long time then. but I think it speaks volumes to your the complexity and the real-time nature and the demands that you have to deal with on a day in, day out basis, right? So that's phenomenal, yeah. Michael. Thank you for sharing. Because I think
one of the other things that might not be obvious is after we cut all these prices, we then need to publish them to our clients. So we do that all through SingleStore too. So we will create all these prices, we will put them somewhere else, and we have a homegrown WebSocket that queries that table an awful lot to make sure we're keeping up with the prices we need to publish.
Wow. Okay. So I think this kind of sets up the perfect world of, okay, so these are some of the demands that you kind of deal with on a day in, day out basis. But so talk to us a little, I think the audience would be really interested in knowing a little bit more talk to us a little bit about your journey. How did you get started with, with the data journey, especially? Like, how did you start powering this platform? You mentioned MySQL earlier. So let's just talk a little bit about how did you get started, and then what was the outcomes and things like that?
Sure. So like we talked about, the data ingestion was really challenging. One of the other things we did that really helped, that I encourage anyone to look at, is we put a layer in between all the writers to the database and the database itself, and we use Kafka for that, and that's worked extremely well. So we've got a durable message bus in between, and if we wanted more single stores, we could restore from backup and then turn on the pipelines and whatever other single store, and they'd all be in sync. We had outages every other day. That's true. Our table of trades would get to a few billion, and then it would not be queryable anymore. And as I'll show you when I screen share, I have one table in SingleStore that has 123 billion rows in it, and it is queryable. Another thing that we struggled with is all of this data I'm talking about is really time series, and we're able to do that as well in SingleStore. So we know when an exchange changed what they refer to as one asset. And so if we want to go back and collect historical trades, we can normalize it correctly. And that was challenging given that we couldn't keep a large history set in one MySQL area. I think just one of the things that led us to SingleStore pretty quickly is your compatibility with the MySQL native language. That was an interesting kind of lead and made SingleStore very promising when I first heard of it.
Very, very interesting. So you mentioned, so you started with MySQL, data ingestion was obviously a challenge, and then the fact that typically these, and I think you guys were with AWS Aurora, the MySQL version of that as the commercial provider, and then where the challenges was that, because of the single node nature of MySQL, you just couldn't scale enough, right? And again, it was impacting the query performance. I'm assuming that's what this locking. Can you just maybe double click on the locking? Like what was the locking issue that you ran into?
So it'd really be when volume spiked and we were getting too many trades. Every writer needs an exclusive lock in MySQL, and the pricing engines can drift a bit from real time. They're not exactly real time just because we need some time to do all those things, even if it's milliseconds. But they would get further and further behind. So then there would be multiple periods all trying to run at the same time, and it would be a deadlock, and the database would fall over. It would just stop accepting any updates, and it would be locked. And we would scramble to do something else. Some scary things we had to try in the middle of the night to get things working, and then figure out how to pull the history from the exchanges. And often we were calling the clients and telling them, sorry, we're running a few hours behind. Yeah, we will make up all those periods as soon as we can.
Right. And again, this kind of goes back to it is built from the ground up as a single node database. So it's not designed for some of these modern requirements, modern application requirements like you guys, what you guys are looking for. And plus to add to the fact that, little or no analytical capabilities, right? Again, because it's an operational database, if you had to do analytics, you probably had to pull the data and put it in a different engine, separate engine that you have to now manage and then move data between them and make sure the data is in sync, right? All of that fun stuff.
Or we'd have our data scientists pulling S3 files and cobbling something together. But it wasn't possible to do anything across the large number of trades in MySQL. That's true.
I hear you. Yeah. Awesome. And then obviously what that meant was you're putting in more money trying to vertically scale the MySQL platform, but obviously that was becoming, I'm assuming, cost expensive and cost prohibitive from your perspective. But I also heard, Michael, so you also mentioned you kind of tried Snowflake and experimented with Snowflake for a little bit. Tell us a little bit more about that journey.
So it was a non-transparent pricing, which in retrospect, I probably should have raised my hand and been more aggressive about finding out how much it costs. I had a sticker shock the first month that we used it, and they weren't forgiving or helpful unless I wanted to sign an immediate multi-year contract, which I wasn't interested in. And I think you've nailed it here that having a predictable cost like we do in SingleStore is really helpful for our budgeting process. Our Kafka provider also has a predictable cost, and we moved away from another that did not. And we really like to keep our costs under control and be thoughtful about, if we want to add something new, here's how much it costs. And to be able to get that right, we need to predict how much things are. And also SingleStore did some things significantly better than Snowflake. Snowflake was better than MySQL in terms of performance, but we got a larger boost moving to SingleStore. Snowflake does have some advantages in that it's possible a client would want to consume our data and they could buy it right from the marketplace. There's one small selling point, but not enough to keep us on Snowflake.
Gotcha. Cost predictability, price performance, and then just the performance itself, right? When it comes to, again, transactions analytics in a single engine, all of that is probably critical for your success. That's fantastic. So, but you mentioned, so I think you kind of laid out the case for, what you were going through, what were the requirements, or where your journey started. So what that meant is now you had to look for a new platform. You started with MySQL, that didn't work. Experiment Snowflake, that didn't work. So you had a list of requirements, and you had to now go look for a hey, what's going to be that platform that's going to help power us and take us to the next level, right? So what were some of the key requirements? And I think you already mentioned some of these, but what were some of the key requirements from your end in terms of the underlying data platform? What were you really looking for? What was your wish list, if you will, when you were shopping around?
So I think a key to me was I was tired getting up in the middle of the night over and over, and I wanted that to stop quickly.
Sure. Yep.
We wanted to be able to query these huge data sets. We wanted to allow for a massive amount of concurrency, and we wanted to query in near real time. At the time, I was thinking I might need a separate ETL tool to control how the data streams in, but I think we got a nice bonus in that SingleStore includes the pipelines.
Yep.
And another thing, we keep finding, because of all this flexibility, new ways to use it. And I was just thinking, we have a later slide we're going to talk about some of the ways we use it. We also use it for logging, which is more recent. CloudWatch got too expensive. So now we use it for logging as well, and no additional cost, and it's a pattern we can follow, and it's working well. As far as low TCO, a lot of people say I'm self-deprecating, but it's surprising that I've done most of the hands-on database work myself. So I do the logical and physical modeling. I do all the pipeline development, and it's pretty straightforward. There are, it's not perfect. Nothing's ever perfect, but it's achievable that someone could go from not knowing what SingleStore is to being able to do about anything themselves. I think the scalability was also key. So as we come up with new requirements, like our 400 millisecond engine, we can scale it out, and we have a lot of options on how to do that. Some of them we've tried and we're using, some of them we're going to explore in the future. Right now we have a single database, which is all of our dev and production, and we have isolation between the two, but we have that all in one physical environment. Some things are really good for that. Like if you want to refresh dev, you just select star from prod and put it into dev. But other things, you have to make sure you're constraining dev. So someone writes a bad query in dev, it doesn't take on prod. And it makes it so scaling, you always have to go 50% bigger. So eventually that's something we'll explore and see if there's a more fine-tuned way. But we certainly needed something that could scale as we came up with new products.
Gotcha. So I heard scalability definitely. Performance for your complex queries, and then the real-time performance, ingestion capabilities were critical for you, and then concurrency you mentioned, right? Like when you have multiple people accessing the same platform, you don't want those timeouts, you don't want those outages that you had with the previous iterations. So scalability, concurrency, highly performant analytical capabilities, and then obviously tied together with the low TCO. So that was the requirements. And then how did SingleStores come by? What are some of the key things that really stood out to you when it came to SingleStore?
Yeah, so I think this took some tuning on our side. So it wasn't like instant to get to the model we have now that's working well. So we actually have separate, we have some of our tables are only row store. So they would replace a product like Redis cache. And we will often save data to more than one table. So we have a trades table that's cache, and we have a trades table that's everything. And that's been really effective rather than taking from one and like once a day trying to copy it into another, because you can control for each of those loads how much resource to give it, how many pipelines to run. The cache table runs 1,000 pipelines a second because it needs to be up to date. And as you watch it run, it can do 10,000 trades some of the time. It could do a few hundred some of the time, but it runs about 1,000 times a second. The version that loads our massive table, that can be a little bit slower. They will be completely in sync after a time, but that can run a little slower. So we got the ability to fine tune like that. It handles streaming data very well. So writing now a new pipeline against a new Kafka topic takes me often less than 15 minutes. So we've got 150 plus pipelines now that are all running at various intervals. We needed the speed that we could do all this reading and writing over and over at all these different intervals. So each one of those pricing engines we saw before, 15 second, 1 second, 400 millisecond, those are all pounding the trades, getting all the trades they need. And when they come up with their answer, they're writing it to another Kafka topic that we then load and then deliver to our clients through all these different means. So loading those and delivering those needs to be incredibly performant, or we'll get further behind. I think the interactive UI is another important one. We had some tools with MySQL, but it was often hard to control and pinpoint what was happening. SingleStore's done some new things with Grafana dashboards that are even more powerful than what you had in the past. But there's a nice UI where we can gauge memory usage, CPU usage, how the pipelines are running, a number of reads and writes and failures on all those per minute, and that's all useful. And there's ways to find the problematic queries. That's pretty straightforward. So you can explain any query, and it'll give you the join path, and you can see if you're doing table scans, or you can record your workflow over some period, and then you can say, oh, this query's using a whole lot of CPU, which is one that we found last week, and now we can go and rewrite that and figure out what we have to do, either make a new index or do something different on the software side, but it's got good tools to let us pinpoint that.
Awesome. So at this point, I'm sure the audience would be curious. Just can you talk a little bit about the architecture today? Like, how does the data flow, and what does the architecture look like today for digital asset research?
Sure. So, not to take you through everything, but we were talking quite a bit about our trading architecture. So we will collect from our exchanges that we rely on the most. We'll collect in duplicate. So we connect to their WebSocket. We have a homegrown application written in C# that runs in Kubernetes and AWS, and that writes to Kafka. And it writes to Kafka along with all of the other. So, for example, Coinbase is one of our trusted exchanges, as is Kraken. So we will have those 4 different, and they're sometimes multi-region, write to a Kafka topic. And then the SingleStore pipelines are consistently running and loading in there. One of the nice things is that because SingleStore is able to be multi-cloud and our EC2s live in Amazon, we have a private network that connects SingleStore to our EC2s, and it makes the networking very fast. And we've got all kinds of processes that are on top of this. So we've got an internal ref master, and that flows into all this normalization we do. We have a way to do scheduling, and depending on what it is, so you can imagine our pricing engines run all the time. So they have their own EC2, and they're always keeping that busy. Our things that run hourly or daily, we tend to use something like a Lambda function in AWS. They're very inexpensive, and those run against SingleStore. We have a number of REST API endpoints that for clients that query every so often, we will typically give those. But for clients that want more real-time data, we will typically give them a WebSocket connection. We have things like end-of-day reports. We have data scientists writing big queries, and we'll do that for things like the ESG report and the exchange vetting. We have queries just to see what we have. So we'll have people all across the firm writing queries to say, oh, do we price this element? Or, how far back does our price go? And lots of experimentation that data science will do.
Awesome, fantastic. One thing caught my mind when you were mentioning about, hey, we didn't need a Redis, or we didn't need another cache, right? Because you obviously to parse some of these through, otherwise you would have probably needed a cache. So so just curious. I mean, obviously you're not just using SingleStore as an analytical database or just as an analytical database, right? So talk to us a little bit more about how, what are the functionalities that you get covered today with SingleStore?
Sure. So it's interesting as we think through each of the components. I'm sure there are a lot of firms that have independent tool for each of these. So you could use like a MySQL for OLTP, and you could use, I had a bad experience with one in Amazon, and we're happy Amazon customers, but I blanked out the name of it, where we wrote a query and it was $1,000 for the one query, because I had to do a lot of stuff. But we've got the ability to write a query that goes across our 123 billion trades. We have all of the pipelines, and that goes from the very simple, like I talked about earlier, where I could do one in 15 minutes. I never like to have too much complexity because it makes things harder to manage, but from time to time we need some that are more complex and do things like lookups or updating more than one aspect at once. And we can write pipelines into stored procedures. It supports that. We have many of them that we're using. And we also can handle all our data transforms there. So we've got functions and views in addition to the procedures that help us with that. And then we have this caching layer where we can make use of the fact that when we're writing quickly, the data sits in a row store before it gets sharded, but we can force it to always be in cache for the things we know we're querying tens of thousands of times a second. And that's where a tool like Redis would come in. Right.
So essentially, it's like a 5-in-1 thing. Like you get the OLTP database with ACID compliance, you get an OLAP, super fast queries. You also have a ingestion with the pipelines. You're talking about 160 pipelines that you run day in, day out. And then you do mention a lot of the data transformations that you can do on the fly, right? As the data lands. And then obviously you get kind of the caching layer as well. So that's a kind of boots, kind of 5 different things, which would have probably needed 5 or 6 different tools and a bunch of data movement otherwise, right? So it's, again, to your point of cutting out complexity, I think that's a great point. And probably that has a big impact on the cost and the bottom line as well, right? Very cool. At this point, Michael, I mean, I think the audience would be interested in just seeing a bunch of stuff. I know you have some cool stuff that you wanted to showcase. So why don't I stop sharing, and I'd love for you to walk us through some of the, the cool things that you guys are working on. So let me just stop my sharing. Pass this to you.
So I think the interesting thing, and when I talk about this, people's eyes get wide when I talk about a table with 123 billion rows. But here it is, and
this is the SingleStore portal, by the way, for the audience. If you're not familiar, this is the SingleStore portal that our customers use to manage their cluster. Yeah.
And I know you have newer portals as well.
Yeah.
I'm a dinosaur in some respects, and there's some things about this old one that I don't have in any others. So I use this from time to time. We talked about bottomless storage, and if we see, this table has 9.53 terabytes of disk that it's using. And because the database will just spill over to S3, we don't run out of room, and we can just keep adding to this, which is pretty amazing. We also have these trades. So this is using some memory because it takes time with the amount of pipelines we run to allow the database to shard. And it's totally transparent to us. I don't have to worry about that. I just have to worry about if I'm overusing the memory and CPU that are allocated, I need to either scale back or buy more capacity. But I don't have to worry about when it's sharding or when it's pulling back from S3.
Michael, can you control plus that screen at all? Some of the audience is saying, can you make this any bigger?
I can try.
There we go. Yeah,
there you go. Perfect.
Thank you.
Perfect. Yeah.
Yeah, so I think just to show so we have something else here that's called a row store. And so this is the same data set, and there's only 3 million rows. Well, that's because it's only got 20 minutes of data in it. And this gets bombarded. So this gets hit tens of thousands of times a second with millisecond. I don't know if they're single millisecond. I think they're in the tens of millisecond.
Okay.
The return. It's wicked fast.
Mm.
One of the other things that I was concerned about originally is controlling joins. Because if you think about a highly sharded table, so we've got 96 partitions on this database. So everything is sharded 96 ways. And if you go to do a join on a table that exists in 96 partitions with another table that's in 96 partitions, you can imagine the join path can be very complex. But usually there's a way in SingleStore, and you've thought of something to counteract that problem. So there's something called a reference table that we use for things like, yeah, maybe I won't give away all our secret sauce in this meeting.
Yeah, maybe not.
What it allows you to do is run things at the master level. And that means it's guaranteed that the data set you're looking to join will exist in the same partition as whatever you're querying. So we do that with things like asset and exchange. We make those reference tables, and that's useful.
Can you also talk about the pipelines? I'd love to see the pipelines, and I know you have a dashboard or something with the pipelines.
Yeah, so I can see all of them here. I can pull up what they're doing.
Yep.
Because even though I don't think I wrote all of them. I wrote the majority myself, but I don't remember all of them, of course. I can pull up quickly what they're doing. And also, with your new Grafana dashboards, I can see how they're behaving, and I can drill into different time periods. So we're looking at last 3 hours. I could drill in and out. If we were having any issues down here, I would see the pipeline errors. They're pretty rare. And I think one thing that was a bit strange to me is when you're running as often as we are, and I have that one pipeline that runs 1,000 times a second, that one will fail. It'll fail probably 1 out of 500 or 600 times, and it just doesn't matter. It will. The next run will work, and you don't get an error state for that, but you can see it in the logs that it happens. And we've been able to trace that to there's DNS issues with AWS from time to time. But if it really errored out, like in development, they'll do from time to time, where if you have a field that is not nullable, you don't put a default in your pipeline, the pipeline will keep trying to load and will eventually stop and will error out. And you'd be able to see that here.
Yeah, but I think 1,000 times in a second, right? And that's the extent of ingest that you guys are doing, and you can just see that live here in terms of how much data you're ingesting. Fantastic. We have tons of questions, Michael. So I know I would love to see this all day. I'm sure the audience would love to see this, but there's tons of questions. So I think maybe we can start to wrap up and get into the Q&A. Let me go back, but before we jump into the Q&A though, can you talk a little bit about, okay, what does all of this is great, right? I mean, this is an enabling technology. This is the electricity for you, right? You guys have the television, right? What does this mean for the business? Like, what can you do now that you couldn't do before? What are some of the business impacts that you are now able to achieve with SingleStore?
So I think often when we have a new client coming on board, we sell them what we have, but then there's some small difference of what we have to give them. There's some other piece of information. There's some other thing that we haven't yet collected or that we have and we don't have it aggregated like that.
Yep.
And because of all the flexibility, we're typically able to turn something like that around in hours instead of days. So I think it's coming up with new products, testing them in the market, seeing if there's product fit, and being able to refine them quickly has been really helpful for us.
Very cool. Very cool. And then in terms of operational impacts, I know you have a slide here with some. Do you want to just maybe quickly touch upon what was before versus what's now in terms of operational impacts?
Yeah, so I think one of the great things is we don't have to have maintenance windows. So we recently upgraded to SingleStore 8.1, and we were able to do that in a way that everything was still running while it was taking place. And you know, I have the confidence that if we needed to do 10 times the volume because we had a client that was willing to pay for something that was 10 times as big, I could go into the portal and click something and the database would scale up to that level. And that's something I don't have to think about anymore. And I can focus on, there's many other tech problems beyond the database, but I can focus on some of those instead. And that's been really, really useful for me. Fantastic.
100,000x faster performance, faster data access, and then even with 10 to 20x 10x now, and then you could grow to another 100x probably in the next coming years, right? And all at a lower TCO. So that's a phenomenal storyline and a proposition there. So I know, Matt, we probably have tons of questions that have already come in. So I know we have a few minutes. So let's just jump to Q. By the way, this is super interesting, Michael. Just you know, we could do this probably for another 2 hours, I guess. We can have this conversation.
I agree. It's always interesting for me too.
Yeah, this is amazing. Matt, why don't we get into some questions and then
that sounds great. I'll rattle these up. We got more than we could ever answer, so I'll try to go quickly. Michael, did you try any other databases other than SingleStore when you were planning to replace MySQL?
No. And I think that's one of the things that being at a startup is we could have done a thorough study and tested a number of them, but we were just looking for something to solve our problem quickly within our budget. And once SingleStore was able to meet our need, we stopped looking. I'm always reading about things and I'm curious about Postgres and ClickHouse and you know many of the others, but we didn't seriously evaluate any others.
Good stuff. Irfan asked, would Michael be willing to do a select star from one of the tables and see how much time it takes?
Why not? So someone has to stop sharing so I can go back and I will share.
Oh, yeah. Okay.
Let's do it.
There you go. Live demo time. As he's doing, Matt, any other questions that might be?
Yeah, this one I'll give to you, Vijay. Can you talk about security or enterprise features of SingleStore?
Okay, I can rattle off all of the security features, but let me just tell you this. 5 of the top 10 banks run on SingleStore, right? Some of the most regulated industries and customers run on SingleStore. So you know, again, we have all of the security certifications that typically a mission critical enterprise customers demand. So all of that is in place, right? So security has never been a bottleneck from our perspective. So it should meet your enterprise needs for mission critical applications. If it does for banks and insurance companies, I'm sure it'll probably be helpful for you as well.
All right, so I've not run it, so just so we can see how long it's going to take. And I thought we'd query our cache table of trades. That took 306 milliseconds, which is actually really slow.
Which is slow compared to,
much worse performance than we get. and I think the first time you run a query like this, it's got to make all the connections. So if we run it again, yeah, there we go. This is more like what we would typically get. We would typically get sub 100 millisecond.
So that is just the audience confirming that I was not BSing on the slides and we were just not paid to do this, right? So this is real life where he's live on Michael's database. So awesome. Thank you, Michael. This is amazing.
I like the challenge.
Yeah. I see Colin Hall chimed in and says, I think if you look at the actual profile, this query is closer to 20 milliseconds. Thank you for that note, Colin.
I believe it. And when our custom C# program is querying, we're getting better performance. I think it looks 30 to 40 typically, but it's faster than what we see from the portal.
Awesome. I see another audience, if you're willing, it says, while doing SingleStore, can we also run an analytics query as well?
So one thing we could do is, in the remaining 3 minutes, we probably can't do anything too complex.
You have to get Michael for another webinar just to do ask me anything from audience and just do.
Tell me if you want to skip one, Michael, because we've got other questions.
No, I'll tell you anecdotally, if we picked a day from 5 years ago and tried to pull up the exchange trades, it would take a long time, but it would come back. So in MySQL, a query like that would never come back. But in SingleStore, because of what we talked about today, it's got to pull from S3, and S3 is not very fast. It's enormous and can handle any size of storage, but it's not fast. So that query could take minutes, tens of minutes, but it will return because we use it. And if we do another session, I'm happy to show that, or the audience could construct criteria.
We're getting lots of people saying we need more webinars with Michael. So
there you go.
I don't know if you're willing to answer this one, but we did get a question. What is the price per month that DAR is paying to use SingleStore? And I don't know if you're willing to give percentages or ballparks or anything, but that was a question that came up.
I feel like if I threw out the number, there's not any context in terms of our overall spend. So I think about the database, like what is it in terms of how much we spend on infrastructure in total? So we buy compute from AWS, we buy Kafka from Ivan, and it's in the order of 35 to 40% of our total infrastructure spend, which for a heavily data intensive company, I think that's a healthy place for it to be. I think it was closer to 50 to 60% when we were on MySQL. Without taking through every component in our financials, I don't think it makes sense to go any deeper than that. But
yeah, no, I think that makes sense.
Great answer. Okay, Vijay, I know we're at time. Anything else you want to mention before I wrap us up here?
No, I think we covered all. Probably we'll take up on that offer, Michael. Hopefully, if you're game, we'll do another webinar with Michael, hopefully soon, and we can just do an AMA with Michael and the audience.
Let's have people. I actually like that kind of game. Like, can we look up all the things that are like this or like this? And how fast can I write that query?
Good stuff.
The audience could quiz me. I like it.
So reminder to everyone, today only we're doing that $25 discount codes to the upcoming AI conference. So I'll put that in the chat one more time, and then let's talk about the winner to the AirPods. Let's see here. Congratulations to our winner for today, Anurag Gupta. You are the winner of our branded AirPods Pro. Congratulations. If that's not you, don't fret. We're going to give one more chance to win. All you need to do is try out SingleStore sometime today. We're going to keep an eye on that link that we shared at the beginning of the session. You'll also get an email with that link. So one more chance to win AirPods today. Thank you so much. This was an awesome discussion, Michael and Vijay, and thank you to everyone in our audience for joining. Have a great rest of your day, everyone.
Thank you all.
Thanks.
You, Michael.
Bye-bye.
Thank you very much.
Bye. Bye.